In this and the next few videos, I want to tell you about a machine learning application example or a machine learning application case study centered around an application called Photo OCR. There are three reasons why I want to do this. First, I wanted to show you an example of how a complex machine learning system can be pulled together. Second, I want to talk about the concept of a machine learning pipeline and how to allocate resources when you're trying to decide what to do next. And this can be either in the context of you working by yourself on a big application, or it can be in the context of a team of developers trying to build a complex application together. And third and finally, the Photo OCR problem also gives me an excuse to tell you about just a couple more interesting ideas for machine learning. One is some ideas on how to apply machine learning to computer vision problems, and second is the idea of artificial data synthesis, which we'll see in a couple of videos. So let's start by talking about what is the Photo OCR problem. Photo OCR stands for Photo Optical Character Recognition. With the growth of digital photography and more recently the growth of cameras in our cell phones, we now have tons of digital pictures that we take all over the place. And one of the things that has interested many developers is how to get our computers to understand the content of these pictures a little bit better. The Photo OCR problem focuses on how to get computers to read the text that appears in images that we take. Given an image like this, it might be nice if the computer can read the text in this image so that if you're trying to look for this picture again, you could type in the words, Lulubee's Antique Mall, and have it automatically pull up this picture so that you're not spending lots of time digging through your photo collection of maybe hundreds or thousands of pictures in order to find this. So the Photo OCR problem does exactly this, and it does so in several steps. First, given a picture, it has to look through the image and detect where is there text in the picture. And after it has done that, or if it successfully does that, it then has to look at these text regions and actually read the text in those regions. And hopefully, if it reads it correctly, it'll come up with these transcriptions of what is the text that appears in the image. Whereas OCR, or Optical Character Recognition of scanned documents, is a relatively easier problem, doing OCR from photographs today is still considered a very difficult machine learning problem. And if you can do this, not only can this help our computers to understand the content of our outdoor images better, there are also applications like helping blind people. For example, if you could provide to a blind person a camera that can look at what's in front of them and just tell them what are the words that may be on the street sign in front of them. And there are also researchers today working on Photo OCR to help with car navigation systems. For example, imagine if your car could read the street signs and help you navigate to your destination. In order to perform Photo OCR, here's what we can do. First, we can go through the image and find the regions where there's text in the image. So shown here is one example of text in the image that a Photo OCR system may find. Second, given the rectangle around that text region, we can then do character segmentation, where we might take this text box that says Antique Mall and try to segment it out into the locations of the individual characters. And finally, having segmented out into individual characters, we can then run a classifier which looks at the images of the individual characters and tries to figure out that the first character is an A, the second character is an N, the third character is a T, and so on. So that by doing all that, hopefully you can then figure out that this phrase is Lulubee's Antique Mall, and similarly for some of the other words that appear in that image. I should say that there's some Photo OCR systems that do even more complex things, like a bit of spelling correction at the end. So if, for example, your character segmentation and character classification system tells you that it sees the word C1EANING, then a sort of spelling correction system might tell you that this is probably the word cleaning, and your character classification algorithm had just mistaken the L for a 1. But for the purpose of what I want to do in this video, let's ignore this last step and just focus on the system that does these three steps of text detection, character segmentation, and character classification. A system like this is what we call a machine learning pipeline. In particular, here's a picture showing the Photo OCR pipeline. We have an image which is then fed to the text detection system, And having detected the text regions, we then segment out the characters, the individual characters in the text, and finally we recognize the individual characters. In many complex machine learning systems, these sorts of pipelines are common, where you can have multiple modules, in this example the text detection, character segmentation, character recognition modules, each of which may be a machine learning component, or sometimes it may not be a machine learning component, but to have a set of modules that act one after another on some piece of data in order to produce the output you want, which in the photo OCR example is the final transcription of the text that appeared in the image. If you're designing a machine learning system, one of the most important decisions will often be exactly what is the pipeline that you want to put together. In other words, given the photo OCR problem, how do you break this problem down into a sequence of different modules? And your design of the pipeline and the performance of each of the modules in your pipeline will often have a big impact on the final performance of your overall algorithm. If you have a team of engineers working on a problem like this, it's also very common to have different individuals work on different modules. So I could easily imagine text detection easily being the task of anywhere from 1 to 5 engineers, character segmentation maybe another 1 to 5 engineers, and character recognition being another 1 to 5 engineers. And so having a pipeline like this often offers a natural way to divide up the workload amongst different members of an engineering team as well. Although, of course, all of this work could also be done by just one person if that's how you want to do it. In complex machine learning systems, the idea of a pipeline or of a machine learning pipeline is pretty pervasive. And what you just saw is a specific example of how a photo OCR pipeline might work. In the next few videos, I'll tell you a little bit more about this pipeline, and we'll continue to use this as an example to illustrate, I think, a few more key concepts of machine learning.